Welcome back. We are going to talk about algebraic vectors. So I will admit we're kind of treading in new territory here as far as me not necessarily going from a prior script that I've had for this course and refined over the years, knowing that, frankly, we don't have the time to do that. So I will apologize in advance that, we might get to a phase where I'm like, oh crap, I'm gonna have to back up and kind of teach a section that I had skipped over because it's a necessity. I'm hoping that's not going to be the case, but I'm just warning that it may be the case. So anyways, algebraic vectors, here we go. So we're going to break algebraic vectors into two pieces. So we think about algebraic vectors first off in R2, so two space vectors. Algebraic vectors in two space are of the form x comma y, such that x and y are both members of the reals. And so algebraic vectors are listed as ordered pairs. The ordered pairs are where the head of the vector is, the tail is at the origin, right? So think about when we graph algebraic vectors. So if we're going to graph an algebraic vector, so imagine that I want to graph the algebraic vector 2, 5. So the way we would do that is we can pull one of these out. I'm going to make that a little bit smaller. It doesn't need to be that big. And then, right, so when we go to graph this vector, what we're going to have, of course, is that it's going to go 2, 5. Up we go right here. And the vector itself is going to be starting from the origin, as always, and its head is going to be at 2, 5, right? And so we would label this vector. We could say this is vector v, and it is the vector 2, 5. And so nothing mysterious, nothing new. So one way we can name that vector is just to call it v. Alternatively, I don't know color. Let's go that color. If we said, all right, this point itself, and we're going to have to get used to this. It's kind of weird because sometimes when you list an ordered pair, it might be a point. Sometimes when you list an ordered pair, it's going to be a vector, and often it's contextually that you're going to have to figure that out. It's not meant to be a mystery, but we're going to get used to it. So imagine that point was A. So another way that we could reference this vector is we could say that is vector OA. Okay, and that arrow is meant to be over the entire roof of that vector. Go back here. So OA, like that. And so the O here references the origin, right? So algebraic vectors are always of the form O something if you're gonna list them like that. Until we get into other algebraic vectors that don't have an O, and we're going to talk about that in a bit. So there we go. So we've got that for this OA vector, it has a tail that's at the origin, so 0, 0. And then it's got a head that's at 2, 5. Right? There it is. Lovely, lovely, lovely. So that is in R2. Nothing mysterious about that, right? Easy peasy. Let's kick it up a notch, children. And we're venturing into a brave new frontier here. And this is going to be, now we're going to do vectors in R3. Dun, dun, dun. Okay. So similarly, you can imagine that we are not going to have ordered pairs anymore. We are going to have ordered triples, right? So we're going to have an X, a Y, and a Z such that X, Y, and Z are all members of the reals, right? So ordered triple, interesting. So we're going to actually have to learn how to graph on a two-dimensional medium on paper, a ordered triple, a vector in 3 space. So the easiest way to do that is to jump right in. So as an example, we are going to plot. To start with, we're going to plot just the point P, and we'll do 3, 4, -2. Okay, 3, 4, -2. So first things first, we have to learn how to draw our axes. So I have this, where we at school, I would print out a whole bunch of sheets that had multiples of these axes on them. Oops, stop that. Now, the question might become, or I hope the question is coming to your mind, well, which axis is which? And I know our instinct might be, well, of course, this axis down here is going to be X and this axis is going to be Y, which by default would mean that this axis is Z. Sadly, that's not the case. Well, not sadly, but sadly for you, because that's what you thought, right, Jad? You were thinking that. I know you were. So that's not it. What we have is this is the x-axis. You're like, what? What? And this is the y-axis. And of course, this is the z-axis. And where I have placed those letters are the positive side of the axis. So let's get, I think that's red. So this is the positive end of the axis. This is the positive end of the axis. And this is also the positive end of the axis, which of course then by default means that this is the negative end of the axis, the negative end of the axis, and the negative end of the axis. Okay, so that's the first thing. That is how we are always, always, always going to orient ourselves. There's something called the right-hand rule, and it's going to be pretty hard to convey. I'm going to see if maybe I can find a video that someone else has done that's conveying the right-hand rule. Just suffice it to say that this is how we will always label our axes. Positive x is coming out towards you, negative x is going away from you. Oops. Positive y is to the right, negative y is to the left, and z is going up and down. So if you kind of like, if you think that if we were to make a parallelepiped or a parallelogram to start with of this, this is sort of, the plane that would be, if you think about it, flat on our desk, right? So this is sort of flat on the desk. So the x and the y axis kind of make a flat plane, and then the z-axis goes up and down through that, right? So there's up, there's down. So x and y form the horizontal plane that you're writing upon if you're writing on a horizontal desk, and the z-axis pierces that, goes straight up and straight down, right? So that is how those are oriented, and that's really, really important that we understand that and that we are consistent in that. So coming back to this point 3, 4, -2. So how are we going to convey that? So what I'm going to do is I'm going to go out, and I don't really have a scale on these. I'm going to, just set this up at home. At school, I have one that has it. So I'm going to say, okay, there's about 3. So we're going to go out 1, 2, 3. So there's I've accounted for the 3, and then 4. Okay, so 4. This is, so I'm going to, x, y, and z, of course, not z, z. 4 on the positive z-axis. So try and keep the spacing comparable. There's 1, there's 2, there's 3, and there is 4. So this sort of distance right there, I need to traverse out that distance from this spot right here. So it's going to take me out to about there. So that's accounted for 3 and 4. So 3 out, 4 across, maybe a little bit further than that even. So let's go about out to here. And then the z-axis is -2. So I'm going to go 1, 2. So we need to go down about that much. So if I need to go over here and I need to go down about that much, and there's my point, right? There's my point. I'm going to call that point P, and that is 3, 4, -2. But I mean, if I didn't have any other information that's going on right there, how would you know that that wasn't immediately on the XY plane, right? You could imagine that maybe that's an X coordinate of, I don't know, like 5 and a Y coordinate of 6, right? So why couldn't this point be 5, 6, and then 0? It's not up or down at all. Well, it absolutely could. There is no reason that if I were to just draw a dot, randomly out here, that there's not an infinite number of different combinations that would end up with the dot in a similar, precarious position. So what we're going to do is we're going to add in parallelograms that add depth to this, that will allow us to more readily see that this is in fact at 3, 4, -2. And for some of you, this will be second nature and you'll be able to do it easy peasy. And for some of you, you are going to lament the fact that you did not take art in your earlier years. So here we go. I'm going to do this with some different colors, and you'll see why in a moment, just to kind of help us figure this out. So this goes down too. So I'm going to say, all right, everywhere I know that this entire thing needs to be below the XY plane. And so this is too thick. I hate that it's so thick. All right, come back here. So I'm going to go ahead and I'm going to drop these down. And you're like, what is going on? Okay, I'm going to put that down like that. Next, so I think that's green. I'm going to add some with this blue. Let's pretend this is blue. I'm going to say, all right, I'm going to go over here. This is how much I've gone out. And you're like, wow, what's going on? So I am actually going to form this is going to be called, this is just going to be a rectangular prism for now. It's also a parallelepiped, and we'll get to that in a second. And you're like, what's going on? So then I'll get, I can't tell. Is that red? I don't know. I'm thinking this one's red. So over here we go, revert, and zoop. Now, you don't have to do it color coordinated like what I'm doing, but what this offers us is you can see some symmetry that's going to happen here. So then I'm going to go back to that green color. Is that the right color? That doesn't match, or doesn't match. I can't even tell. So here we go. So all of a sudden you're kind of seeing, oh, there is the XY plane. I can see that it projects underneath that. So I'm going to go back to my blue here and then say, here we go, and here we go. And so you can see where we're now forming up that we actually have a rectangular prism. And that was red again, wasn't it? Yeah, it was red. I'm going to color that back in. And so by doing this, by then saying there is the point that we're interested in, by having added this rectangular prism in, you can see, oh, I've gone out a distance, I've gone across a distance, and I've gone down a distance. And you can see that, oh, the out distance has got to be 3, the across distance has got to be 4, and the down distance has got to be, I'm going to put the -2 in, but yeah, -2. And so by adding in this parallelogram, or this parallelepiped is what it really is, a special case, but it's a rectangular prism. What we can see is we can see the depth, and that will help help our mind kind of square away that, oh yeah, this point here is actually below the XY plane. Okay, so by adding that in, what we can see is that it just helps us kind of secure in our mind where that point is. My cat is going crazy. Okay, so let's try another one. And so I'm going to just say I would like you to graph the point. How about if we did -2, -7, 1? So graph -2, -7, 1. And actually, why don't we graph that as a vector? So let's say that this is vector v. I would like you to graph that vector. So to start with, what you're going to do is you're going to do the same thing, and you're going to graph the point. So start by graphing the point. So draw your axes in. So draw your x in what classically we think of x and y, and then draw one that kind of protrudes this direction, and label them x, y, and z, and see if you can get that point in roughly the right place, and then add the rectangular prism to add some depth to it. Pause the video, come on back, and I'm going to go ahead and I'm going to do the same thing, but I'd like you to try it on your own. So here we go. So I'm going to go and grab my axes. Quick story while I'm doing this. Last night, Brianna came into our room at about 2 o'clock in the morning, scared the living Jesus out of me. And she's like, oh my God, there's some woman being attacked. And we're like, what are you talking about? There's some woman screaming, some woman screaming. I'm like, you're on crack, child. Just like my cat. Anyway, and it turned out that when we actually listened, it sounded like someone was being stabbed repeatedly. But what it ended up being, from having listened to animal sounds on the YouTubes, it sounds like it was a fox cry. If you're bored, going, or maybe I'll put it on Google Classroom because it's curriculum material. I'm sure hearing a fox going crazy. But yeah, it scared the crap out of all of us last night. Anyway, on we go. So here we go. So -2, -7, 1. So -2 is my x coordinate. Okay, that's going to be in red, I guess. And then my y coordinate, I'm going to do it in blue. and it's -7. And then the z coordinate is going to be in, oh, jeepers. Is that green? I think that's green. Z. It doesn't look green. I don't know. So -2 for my x. Go back to the red. So I'm going to go and I'm going to say, all right, 1, 2. And so there's my -2 for my x. And -7 for my y. So this is the y-axis. So 1, 2, 3, 4, 5, 6, 7. Right about there. There's my -7 for my y. And then my z is up 1. Was that what it was? I think so. And then up 1, so up to about here. And you're like, well, that doesn't get me anywhere. Well, no, it doesn't. But you can kind of predict how this is going to work out. So I'm going to say this piece here, it's going to be the exact same as this piece up here. So I have the fortunate circumstance of being able to do this. Clone. And then drag that up to help me define this box. Okay. And then why? Oh, crap. The X is in red. So go here and say, all right, this guy is going to go, I think I've chosen poorly, whatever. There, that's good. Is this still red? Yeah, red. All right, so this guy goes, oh, that's not straight. Here, like this. So then I'm going to take that and clone that. Now, you should absolutely be breaking out a ruler here if you've not yet done so. And John, looking at you, buddy, a pencil would be in your interest, right? We are going to be making mistakes and erasing, I promise you. My dishwasher's done. There we go. And so then this guy here. So that was it green? I think it was green. There. So it's still not a pen. Be a pen, please. There we go. And that's not green anymore. Damn it. Green. So I'm going to take that guy and watch what we're going to do. I'm going to actually set an infinite cloner because I'm going to use a bunch of these. So from every corner, because I know I want to define a rectangular prism, I'm going to put one of these up spikes. That's terrible. Oh, well, there it goes. And then another one over on this up corner. So you should be, dragging your ruler over and raising the roof of this box the same dimension on all of those things. And then go back here and say, clone that guy and join the top of the box like that. And then clone it again and join the top of this side of the box. And then similarly, this color, yeah, whatever. No, doesn't look like one. Nope, stop that. This, whatever. Clone that, and then put it on top, and then clone that, and then put it on top over here. And you can kind of see that we've got some dimensionality that raises above the XY plane, and it is, on the negative side of the Z axis, excuse me, and it is behind the Y axis. So now we wanted to make this a vector. So this vector V has a head at -2, -7, 1. So let's grab that color and make it thin. And say, all right, so that is where the head of the vector terminates, and it starts from here and goes out to there. So I'm going to draw that vector in. I'm going to make it blue because I like blue, and I'm going to make it thin because it's easier to see. And so then it starts from the origin, as they always do, and it goes out, and you can't even see the head, that's too small. Goes on out to there, and you can see that now we have a vector that starts at the origin and terminates there, and you can see that it goes back and then to the left and up. And because we have that rectangular prism, that's what we're able to tell. Okay, so there we go. So there is that vector. Okay, so we can draw vectors in 3 space, and we can draw points in 3 space. And this is actually a skill that, on tests, I would have assessed that you could draw that, and you could draw it accurately. And certainly when I went off to post-secondary at Waterloo, I had to do this kind of thing in my, I guess it was classical algebra class 135 and 136. Yeah, so there we go. So now let's try, I don't know, maybe do one more, because honestly, this is a skill that is portable and you need. and I'll try to distract you less and actually just do it. So what I would like to do is let us graph the vector. How about the vector OM? And the vector OM is going to be 5, -4, -3. Okay, so go to it, graph that, and I'm going to do the same thing. Okay, so I want a thinner line. There we go. So 5, 1, 2, 3, 4, 5. Loop there. So, and then -4, 1, 2, 1, 2, 3, 4, to about there, and then -3, 1, 2, 3, to about there. Now I'm going to make use of my tools here, my electric ruler, that I guess, and make it a little bit thinner. All right, so I'm going to just put these all with the same color because I think you get the idea of how these guys work. Oh, crap. Go back to my tool. Dang it. Here we go. There, and then there. Okay, so now, and I always do this in my own practice. Like if I was drawing this by hand, I would have a ruler out and I would start with those and then kind of keep that same angle on the ruler and drag it over and, mark the length on my ruler as I did that and come and put it over here. So I have the luxury of going like this and saying clone. And so I will always, make an effort at creating a plane first. And what I mean by that is by doing that, you can kind of see that there is my XY plane. So this face right here sits immediately on the XY plane. And then I, will start to add in the other dimensions. And so everywhere there's a corner, vertex, as it were, we can go and we can do that. And so then you're like, oh, there's the box. I'm starting to see it now. And so then we just then close this box in and we're good to go. Clone that. And clone that. Okay, so there's a rough attempt at that. And you can see the dimensionality of it. You can see that it projects forwards to the left and then downwards. And so then I'm going to label this point with whatever friggin' color that was. I don't even know. That maybe. Put it here. And then what we have is we have a vector, and we can see it starts at the origin and goes out to point M. So there is the vector. And it's important. I mean, I haven't been going over the top to indicate this, but notice that there is a point, like an arrow on the end of that vector. And that arrow is really, really important because that tells me the direction, that vector goes. And you're like, well, it kind of has to, because it starts from the origin and goes to M. You're right, it does. But we're going to get to a point where the vectors don't necessarily have to begin from the origin. They can go elsewhere. We're going to get into a vector that's like AB that goes from two, relatively random points in 3 space from one vector to the other. So having the arrow on the vector indicating the direction it's going is crucial and it's necessary. Okay. Awesome. So I think we're probably, relatively proficient at that, which is lovely. Imagine that I came along here and I said, oh, well, I want you to graph the following. And so I'm going to say that. Here you go. I would like you to graph. Imagine the following. I want you to graph. How about we make it Z equals 1? You're like, what? That doesn't tell me anything. It actually tells us more than you might guess. Okay. So I'm going to pull this out. Grab this, like this. Here we go. Now, Z equals 1. You're like, that's not even a point. It's more than a point. It's pretty cool. This is actually the equation, super simple equation. It's the equation of a plane. Okay. So I'm going to do an aside because I like asides. I hated them when I was in university, but I like doing them now that I'm a teacher. So here's an aside. Recall, x equals 4 in 2 space. So imagine we were doing an R2 that we had to graph x equals 4. So if I said, okay, go graph x equals 4, you draw your axes, pretend these had arrows at both ends. I'm not going to take the time. x equals 4, you're like, well, that's just a vertical line at, well, x equals 4, right? So that's what that would look like. It would look like this. So there is 4. There's my line of x equals 4. So when we have x equals 4 back in R2, what it meant was we only care about the x value. The y value can be whatever the hell it wants, right? And so that means that, the y value of 6 is good, the y value of 2 is good, the y value of -5 is good. But for all of those, x is equal to 4. A similar concept is happening here. I have said that z equals 1. Well, by default, what that means is that z is always 1, and I don't care what x and y are. So conceptually, what we're going to do is we're going to be like, all right, well, there's 1 right there. There's z equals 1. And every other point that has a z value of 1 is valid. So that means if I were to say, give me an ordered triple that satisfies this, you'd say, well, I don't know, 5, -6, and 1, right? And if I asked everybody in the class to generate them, these would always just be random numbers, but whatever they are, this has to be 1. So what we're going to get out of this is actually a plane that is parallel to the xy plane, and this is x and this is y and this is z. And so, what we have is we have this plane that is parallel to the xy plane that goes all the way in every dimension. That's pretty hard to represent. I'll do my best. This is one of those things that when I was in university, the TA would, draw it and you'd chuckle and you'd be like, that's garbage. And then you'd say, well, do it yourself. And you'd give it a whirl and you'd be like, man, you're awesome at this. I don't think anyone's going to say I'm awesome at this, but you can make me feel good. Here we go. So that's not really as parallel as it should be, but whatever. Right, so you get the idea that what we have here is a plane that is hovering just above the xy plane, but parallel to it. That one wasn't very good. Whatever. Right, so here we have the plane. So this is actually a plane that's parallel to the xy plane, right? And so that is z equals 1. So imagine that instead I said, oh, I want you to graph the plane. And so go ahead, I'd like you to give it a whirl. Graph the plane about y equals -3. So go ahead, give it a whirl, and I'll do the same thing. My cat's an idiot. Scratching on something. All right. So y equals -3. So this is y positive over here. So y negative is over here. So let's call this spot right here y equals -3. Now, this plane is going to be parallel to the zx plane. So imagine I'm doing these hand motions that you aren't seeing, but imagine that we had a sheet of paper that, laid parallel or up against the zx axis. So, yeah, so here we go. So if we had, this would be the ZX plane, right? There's the ZX plane. But what we're going to do is we're not going to have the ZX plane. We're going to have to shift it over, right? And so I'm going to take those guys and I'm going to say, well, no, you actually need to be over here-ish. But I'm going to clone you. Clone. Oh, Sammy wants to be in Brianna's room. It's bedtime, and that's where. Yeah, okay. That's why he's being an idiot. Okay, so clone. Right. So extend that back a little farther. And then similarly here. And you go as well, like this. And you go as well, like this. Clone you. Put you down here. Right, so it's not as easy to see certainly, but that would be then the plane of y equals -3. Okay, so now I'm going to give you some insight. Certainly, not all planes are going to be parallel to other, easy planes like the XZ plane or the XY plane or the ZX plane or the ZY plane. They're not always going to be parallel to that. They can be, at an angle. They don't have to go through, the origin. They don't have to go through any particular point. And so the equation to represent those planes is substantially more challenging, but that's definitely, where we are headed. We are going to be going to that spot. That is what we're going to be, our ultimate goal is. But we're not there yet. Okay, so lovely. Awesome. So I think I'm going to call that the lesson for the day. And I realize now that I didn't post homework for the stuff for the last lesson last week. I'm not all that concerned about that. That was more kind of laying ground rules, and I'll add to that as we go, as we need it. But I am going to actually add some stuff for this one in particular. So have a lovely day.